LiftWEC project aims to develop a novel and commercially attractive wave energy converter. Specifically, the idea is to exploit hydrodynamic lift forces that are generated by a rotating hydrofoil interacting with ocean waves. A consortium of 10 European universities and companies have been formed for the LiftWEC project. Each partner in the LiftWEC project has been selected because of the specialist knowledge and skills which they can bring to this unique challenge.
My name is Gregory Payne, and with the rest of the team at the École Centrale de Nantes, we are looking after the experimental tank testing side of the LiftWEC project. Experimental tank testing is an important tool in the development of wave energy converters. It allows you to test the performance of a wave energy converter concept at small scale, so at a fraction of the cost of full scale and in a controlled environment. The purpose of experimental tank testing within the LiftWEC project is twofold. First, it is to generate experimental data to validate the numerical models developed by the other project partner. And then it is to investigate the performance of the final LiftWEC concepts.
The LiftWEC project is the lead of the numerical modeling work package. Numerical modeling in this context refers to the hydrodynamic simulation of the flow around the device and how that device interacts with this flow. Numerical models can help us to gain a better overall understanding of the complex flow around the wave energy converter. With simulations, we can assess pressures, velocities and forces for all sorts of design iterations in a non-intrusive and quick way. Instead of building a new model for each new design iteration, we just change a line of code and we already have this new model at our hands. This way we can make predictions of annual power productions for different installation sites in order to know what sort of energy output to expect. Or we could use it to estimate the loads on the hydrofoils so that the structural design of the hydrofoils can be adjusted accordingly to withstand these loads. In the LiftWEC project, we currently use a broad range of numerical methods, from very complex hydrodynamic models which help us to understand details of the flow, like vortices around the hydrofoils, to rather simplified models. If the right simplifications are introduced, this allows us to speed up the simulations significantly, whereas the accuracy of these simulations may stay similar. If we obtain a high computational speed, this allows us to test a broad range of possible designs very quickly, which then allows us to select which designs to build as a physical model, either to test it in a physical experiment or ultimately to generate power.
A combination of analytical, numerical and experimental modelling is being used to develop a fundamental understanding of the hydrodynamics. This understanding will be combined with advanced analytical design techniques, develop a technology which is both robust and low cost. The next steps in the project are to refine the models and finalise a preliminary design for a LiftWEC prototype. It is hoped that this LiftWEC prototype will then be deployed in a real ocean environment to demonstrate the commercial viability of generating energy from waves.